just some updates on these heater PCBs. The RevA has undergone a lot of changes. Here's an original RevA board, and here's what it looks like now. This basically is all resistors, very simple circuit. I've added a thermistor to measure the temperature that works very, very well. What doesn't work well, though, is I actually drilled some holes here thinking that I would isolate the heat from here, the heat source, from actually, heating this up. But actually, it doesn't work the way that I thought it would. It actually makes it hotter because it allows air currents from inside the bay to actually travel in here, and that actually heats this up more. That's why you prototype things. So on the final version, I am going to remove the copper, of course, to keep the heat coming in, but I'm not going to add these holes, which is nice. I didn't want to have to add them. What I've done here is, I mentioned earlier that the cells towards the ends on this side and that side basically get cooler because the cell over here, in addition to just having the sides here, also has the entire broad side of the face there. So what I've done is, one, I've removed some of the resistors. So the last two cells here now only have 8 instead of 9 resistors. You can see that over here. This one actually has 7. I was playing around with that as well. Fortunately, LiBCM already uses a 75 ohm resistor, and this is a 2000 ohm resistor. It's probably going to be much higher. It certainly will be. It'll be 4,000 or 6,000 ohms. So at the end of the day, 6,000 ohms versus 75, you can just populate 75 ohm resistors here once we get the final PCB, and they basically won't put any heat across them. A very, very small amount. So yeah, what I've done over here, and this is very much a hack, is I've added an external set of resistors. My thought being here that we can use this to heat the actual end piece of the cell. So let me show that here. I'm not sure if that's, yeah, this is the right way here. So if we look here, what before we had was this resistor here is the end, and it was basically goes right there on this cell. I've added a new set of resistors that actually go out here. There was some mechanical safety issues here. We don't meet them with this, but there's no conduction here, but we don't have like the 3 millimeters creepage and clearance to this piece of metal here. But it's good enough for prototyping. And what this does is it actually heats this steel enclosure up, and then of course this heat is just bleeding out the front towards the PCB, or on the other side. I haven't put it on the other side, but it'll be there too. On this side, it'll leak out towards the aluminum, but it basically preheats this slightly to minimize the heat gradient, the temperature gradient from here to there without it. So basically this, well, not that, but we'll come back to this side. This allows us to, we're still heating the cell here with this guy on that cell, and then this is just preheating this steel. And so that seems to work pretty well. Again, this PCB is not doing so safely, but the final one will. We basically get 3 millimeters of clearance to this steel at something like 17.5 millimeters. So we do have to actually stack 4 resistors pretty closely here and 4 resistors pretty closely there. The good thing is that it doesn't matter how hot these resistors get, because they're just going into the steel. So these resistors going to the batteries, we need to make sure they're not getting too hot. I think like 55 degrees C is what they're heating up to right now. The cells are not getting that hot. The cells are getting up to like 35, 40 degrees. And of course, I'm running that open loop. I just have the this on. I'm leaving it on for 2 hours. This testing is taking a long time because every time I make a change, I have to heat these cells up and get them to a uniform temperature. Of course, at the end of the day, we'll run closed loop, and we will basically monitor the temperature here, and we will disable all of these resistors whenever the cells get to 25 degrees C or whatever. There will basically be an enable criteria of the ambient temperature, not the batteries. The ambient temperature has to be, say, below 10 degrees Celsius, and once that, as long as that condition is true, we'll heat the cells to 25 or whatever. It doesn't make sense, for example, when you're in a hot area and at night it gets down to, say, 60, and then during the day it's 100. You don't want to be heating the batteries up to 70 degrees Fahrenheit or 23 degrees Celsius. overnight there. So anyway, that'll just be conditional logic. But yeah, this PCB has had a hard week here at the Casa de Sullivan here, and but this is working pretty well. The old sensors that were bolted to the exterior of the battery are now going to be just soldered here. This will be done. It'll look prettier on the next version of the PCB. Yeah, so we basically have 8 resistors here, 8 resistors there, and right now I have 8 resistors here as well. Of course, I'm going to just leave the 9 resistors populated on all the interior ones, and then we can just put 75 ohm resistors to match, for if we want more power. Basically, every resistor you take out of here is going to increase the power by like 10 to 12% approximately. That changes the more you take out, obviously. These resistors are rated for 3/4 watt apiece. That's their boilerplate. They can't actually really take that much current, or power rather. But anyway, having, still with the 8 resistors right now, this is like 1.1 watts versus these interior ones are like 0.8. So it's a it's like 0.86 versus like 1.05 or something. So it's just a little bit more heat. So yeah, other testing I'm going to do on this. I still don't have the 12S PCB, but as soon as it gets here, along with the stencils, I'm going to build another 18S, just a normal 18S, not all these modifications. These modifications have taken a little bit of a while. And then I'm also going to build up a 12S PCB, and I'm basically going to put all 3 of those modules inside of the OEM battery enclosure, and then make sure that the middle module is not getting too hot. And then I have to test both the 18S plus minus configuration and the 18S minus minus configuration. The reason I have to test those is that in one of the configurations, 2 of these modules are backed up to each other. So one of them is right here on a battery, and the other one is basically right here, just a few, maybe 12 millimeters away from it. You need to make sure that that's not a hot spot. So I got to put some temp sensors in there, etc. And what I'll do is I'll put this one in the middle both times so that I can use this temp sensor. It's very, very accurate, which is really nice. Just because it's touching the cells directly. The reason it's on the middle here is so that we get, the middle tends to be the warmest. The middle, like 5 or 6 cells, all tend to be the same temperature, and then they get cooler as you get to the edges. Anyway, I'll throw all 3 of those in a case, make sure everything is going well. I'm being very, very meticulous about doing this testing. Anytime I get close to these lithium batteries, so for example, the LTC 6804, the firmware that's running for the LTC 6804, spent a lot of time on that code. Same thing with this. If this is done poorly, which I don't think it is right now, but still needs some testing, then it could cause the cells to overheat, or like some of the cells to overheat. So we need to test for all of those conditions. And yeah, so that is an update on this. This is not the only thing I'm working on right now, but it's the only thing that I feel like is very pertinent. Still waiting on those parts to come in from Austin, and when they get here, I will make those instructional videos. My next step right now is I'm going to go make the final angle brackets so that I can shoot the videos again. That's the final part I need to make. I have all the material for it and all the tools. I just haven't made the final ones. I just have the prototype ones still. Let's see, other testing I did on this, I cut these here so that I could heat up these resistors warmer or cooler, just to kind of figure out what the resistance needed to be. My goal is really to just use the 2 resistor values, whatever this final value is, say 4K, and then also the 75 ohm that's already on the reel. The reason I only want to use those 2 values is that I'm using every single feeder on my pick and place machine, and so if I add any more parts, then I have to basically pull a reel, or swap reels between builds, which I really don't want to do. So yeah, that is the status of the heater PCBs. This will be a kit, and I do think that my recommendation is going to be that everyone updates to this. It does not a requirement, so if you don't want to take the pack out, if you had someone else install the pack and you don't want to have to pull it back out, then I totally get that. The reason I'm saying that is that the temperature sensors where they were previously mounted, they weren't horribly accurate. So I think the reason I'm not saying you must do this is that these cells do not heat up very much while you're driving. I actually tested that with a thermal camera and onboard temperature sensors. You can kind of see, this is not the actual module I used, but you can see how I attach sensors elsewhere in here to measure the temperature. So when you're driving, the cells do not get that hot, and it makes sense because they're like 1.1 milliohms a piece. So even when you're doing 100 amps across them, which you can't even do very long. So if you had 100 squared times 1 milliohm, it's 10 watts, and you might be doing that for like 30 seconds or whatever. So anyway, I don't think there's a lot of self-heat. So these temperature sensors are very good at measuring external heat. So if the car is cold, for example, eventually they're going to measure correctly. But when you're adding heat continuously with a board like this, now that's not the same, because now you're throwing heat directly into these modules, to these cells rather. So anyway, I'm going to recommend that everyone update this. It will not require any LiBCM PCB changes. That PCB will stay the same, both RevC and RevD. But I will recommend putting these on. It'll literally be as simple as pulling the pack apart, pulling one of these sides down slightly. You don't have to take it off. I'm zoomed way in. Let me zoom out here. So basically pulling this rail down but not off, and then basically sliding that in there like that. It's got pretty illustrative text on it. The connector should be on that side, the hole should be right here, etc. And then you'll have to hook up these high current wires to the, high voltage wires, actually very low current, to the 12S PCB, and then you will need to basically plug this temp sensor in instead of the old one that was there. This is not that. Anyway, that is all for now. Thanks for watching.